Okay, hello, you're welcome to my channel. Now in this video, you want to find the domain of square root of 9 minus x squared. Good. So in our previous video, we solved for the first, second, and third question. That is, we've solved for the domain of the three questions above, right? The three functions. So we want to do the last one in this video. Great. So maybe it's needful for you to go over there and check them out, right? But this one is a little bit more fun than the others anyway. Okay, so let's see. We have a square root of 9 minus x squared. Right, so the domain of this function, we want to solve for it and see what it will give us. Now, this function will be defined, taking note it's a square root. It's only defined for non-negative input. So we start right away by saying that 9 minus x squared should be bigger than or equal to 0. So we do not want the input there to be less than 0. It can be 0 and it can be bigger than 0, right? Good. So 9 minus x squared should be bigger than or equal to 0. What I want to do here is to solve this quadratic inequality. See, here we're having a quadratic inequality, and the way I'm going to tackle this is to, first of all, change this inequality sign to an equation. We're going to have 9 minus x squared is equal to 0. I want to solve for the two values of x that will make this equation to be equal to 0 on the right hand side. That is, that will make the left hand side to be equal to 0 on the right hand side. And by just looking at it, the number that we can square to get 9, such that 9 minus 9 will give us 0, they are only positive and negative 3. Just move 9 to the right hand side, multiply both sides by negative 1, and then you take the square root, and this is what you get. Good. So x is either positive 3 or negative 3. These two values, that is positive 3 or negative 3, these two values of x are called the salient point. Great. Now this salient point will help us to bisect our number line into 3 points or into 3 intervals. Having in mind this is negative 3 and this is positive 3. You know, positive 3 lies on the right hand side of negative 3. Great. Towards the left hand side, we are approaching negative infinity. That is moving towards a negative axis without bounds, and the same thing goes to the positive axis without bounds. All right. So as I said, this is an interval, this is an interval, and this is an interval. Maybe we can give them a name according to the alphabetical order. All right. So we've talked about the first interval at first. We have from negative infinity all the way down to 3. Now, what we want to do here is to pick any number from each of these intervals and then plug them in this inequality. All right. And then we evaluate, we check if that point that we took from each interval, if they satisfy that inequality. If it does, then the whole interval do satisfy. Maybe you can check that out on your own. Test all the numbers in this interval if it is possible. So here, we can see here, negative 4 lies here, negative 5, all the way down to negative 1 million, negative infinity. All right, so we can choose negative 4. We plug it into this inequality. We're going to see into x, all right? So negative 4 in place of x, that will give us 9 minus negative 4 squared. Good. So that's what I've just done. I picked negative 4 from here, put it in place of x. Now when you evaluate negative 4, you square that gives us 16. And 9 minus 16 is going to be less than 0. But this inequality was telling us it should be bigger than or equal to 0. So since this is less than 0, it means that A does not satisfy that inequality, so this interval will be ignored. Great. We do the same thing over here. We look at the second interval B. Between negative 3 and 3, I can see 0, right? We can pick 0. You can choose to pick negative 2, but I'm going to pick 0. You plug in 0 in place of x, that is just 0 squared. 0 squared is just 0, and you're having 9 minus 0, which gives us 9. And 9 is bigger than or equal to 0. That's right. Good. All right, so since this interval satisfies that inequality, so that interval will be taken. Right, so B satisfies that inequality, and that gives us a very nice information about our domain of this function. Now, take note, if you plug in negative 3 into that, in place of x there, negative 3 will also satisfy, because we say it should be either bigger than 0 or equal to 0. If you plug in positive 3 into that inequality, positive 3 also satisfies. That means that the first part of our domain will be of the form from negative 3 all the way down to 3, with negative 3 and 3 included, since they both of them satisfy the interval, right? Good. So you take note of that close bracket, showing that the endpoints of the intervals are inside the interval. So if we're using a parenthesis from -3 to 3, let's say, okay, this tells us that this point is not included. So we're talking about all real numbers from -3 to 3 with -3 and 3 excluded. But right there we are talking about with -3 and 3 included. All right, good. So we are now left to test the third interval, that is the C, if it is going to satisfy that inequality. So from 3 to positive infinity, I can see 4, all right? Good. So we pick 4 from there and we substitute into this inequality. Since this is just squared, all right, the negative of that number will play the same role as the positive of that number, since we are just going to square any value of x. Good. Maybe if we just plug in 4 here, we're going to have 4 squared, which is 16, and 9 minus 16 is going to be negative. It's going to give us a negative result, that is -7. But -7 is not bigger than 0, rather it is less than 0. So which means that this interval does not satisfy. So the only interval is the B, and that is the domain of that given function. Well, that domain there is based on interval notation. If we want to use the set notation, it will be a set containing all real numbers x, right, such that x lies in the interval from -3 to 3, with -3 and 3 included. Right, that is what it means for x to be the domain of this function. It starts from -3 and gets to 3. It can be equal to 3, it can be equal to -3. It will also satisfy that function. Great. All right, thanks for watching, and please subscribe to my channel.